About routing protocols, and the routing protocols, so far we discussed about distance vector routing, and then the other technique is link state routing. Now both are the techniques are for intra-domain routing. Intra-domain routing is a routing which is done inside the autonomous system. So in this link state routing, it is far better than the distance vector routing. It is much stronger, and also it shares many information, like whenever the packets are shared, it shares the information about the nodes which are connected to each router, the cost matrix, and the link is up or down, means everything is shared. And here we are using the Chitra method to find the shortest path. Here we have also seen that in this method, every router is aware about the entire topology. If this is the topology of the internet, then every router is aware about the topology. So in this, what is the procedure? Every node, that is router, will prepare the link state packet. Then this packet is shared with every other routers by the flooding technique, and then the shortest path tree is prepared, and with the help of shortest path tree, routing table is prepared. Now shortest path tree is what? Shortest path tree is a tree that is made up of from the graph, where the root knows the short distance to every other node. And OSPF is a protocol that is working on the link state routing. So again, it is a autonomous system protocol. That means the routing we are doing inside the autonomous system. If you do routing between the autonomous system, it becomes inter-domain routing. But we are discussing about the intra-domain routing. So in this autonomous system, we further divided this autonomous system into smaller areas. We are calling it area 1, area 2, area 3. So area itself is a small internet which consists of networks and routers. So each area is having one router which is called as a gateway router. This gateway router is basically a kind of gateway for this area to interact outside this area. So every area will having one router which is acting as a gateway router. Now all these gateway routers are connected to one network. We call it as a backbone area or a area 0. And this is our autonomous system. Here also we have one router which is acting as a gateway to autonomous system. This is the kind of assumption we are taking when we talk about link state routing, where we have different kinds of links are defined: point-to-point, transient, and stub, and virtual. So point-to-point is direct connection between the two routers. Transient, when many routers are connected to one network, that is transient. And stub means one network connects to one router, and virtual means it's a kind of backup router which is provided in case the main router is getting failed. This is an example, point to point. We have discussed how we are representing here. This is the transient link where many routers are connected to one network. This is one representation which is not efficient. So this is how we are representing the transient network. This is stub link, one network, one router. This is how we are representing. Virtual link is a kind of backup routers. Talk of OSPF packet. So OSPF packet can be sent in 5 scenarios. In the case of RIP, when we discuss RIP, every time we are sending only one kind of packet, but in the OSPF, 5 different kinds are possible. Hello packet, data description packet, link state request, link state update, and link state acknowledgement. Now all the packets are shared among the routers, but we have one special case that is called link state update. Now in this case, in link state update, routers are doing advertisement, so we call it link state advertisement, where router is announcing its status, how many links it is connected, how many routers it is connected. So in link state update, router is actually giving the information of its own status to other routers, and this is called link state advertisement. So link state advertisement is only happening in these 5 cases: router link, network link, summary link to network, summary link to AS boundary router, and external link. Now, what is the meaning of all these 5? Router link means the router is announcing its link to the other router. That is called router link. Network link is announcing of the networks to other router. Now, network link is only possible when you have a transient link. What does that mean? It is a router which connects to, this is point-to-point connection, this is a stub connection. So here the router may say that I have connected to one router which is a point-to-point connection, I have connected to one network which is a stub connection. So this router will be doing this router link update. Okay, so announcing its connection to other routers is called router link update. Network link means wherever you find a router is acting as a designated router. Now, if you remember the scenario, we have a network, we have a router, this is called a stub, and here this router will act as a designated router. Similarly, we have one network and many routers are connected to it, and this is called transient network, transient link. Here out of these 3 routers, one router has to act as a designated router. So in this scenario, we use network links to inform that out of these 3 routers who will be acting as a designated router for a given network. Means you are announcing the information about the network. That is done with the network link. Then we have summary link to AS boundary router. Now what does this mean? This is our autonomous system. Here we have many areas, and all areas are connected to backbone area. We have one here, gateway router is here, gateway, border gateway, and this all connects to this network. This is called backbone. And here we have one autonomous system router. So the router link and network link. Now these type of updates are only used inside the area. We have 5 different kinds are there. So these 2 kinds are used inside the area. Means inside the area, every router is informing to every other router that what is my status, how many links I am connected, how I am connected with the other routers, and what is the status. This is happening with these 2 kind of link. So when this kind of sharing is happening, the routers inside this area is well aware about the structure of this area, but the routers are not aware of what is happening outside, what is the world outside. Now this is informed with the area border router. So area border router will send one packet and tell what is the network to which we are connected, means the network of backbone area. Now this packet is said to be summary link to network, means area border router is informing to everyone that what is the network through which we are connected. Similarly, this is also sending this packet, this is also sending this packet. That means this packet is only delivered by area border router to inform what is the network of the backbone through which we are connected. Then the next is summary link to AS boundary router. Now, if any packet wants to go outside this autonomous system, means want to reach outside this, then how it is possible? It is only possible, it has to go to the autonomous router first. So autonomous router will send the information to the area border router, and area border router will inform to the routers inside this area that what is my address, how you can go to me. That means the purpose of this packet is to inform the address of the autonomous system router. Autonomous system boundary router means this router which is acting as a gateway. Then next packet is external link. Now this is used to inform the routers inside this area that what is the status of the other autonomous system, means what is the status of other routers which is a part of internet. Now autonomous system is just a part of internet. Likewise, we have many autonomous systems are there. So this routers connect to this autonomous system. Now here we are using a concept of inter-domain routing. Inter-domain routing means when you are doing a routing between the 2 autonomous systems. Okay, so here autonomous system maintains some tables that keeps the information about its own system and also the information outside this autonomous system. Now this information is shared to all the routers, so that if router want to send any packet to this autonomous system, can be easily delivered. Because in this structure, we are assuming that every router is actually aware about that entire internet, entire topology of the system is known to the router. So here, this kind of packet is used. So the important point to keep in mind that we have different kind of packets are possible, but all packets are to be used in a different perspective. Every router cannot use all the packets. It can be used by different routers by a different perspective. For example, these can be used mainly inside the area. This is used by the area border router. Okay, this is used by the autonomous system border router, and this is also used, but we need some more information. Now, in our discussion, we are focusing mainly on these two parts. Here we will only see the packet structure. So OSPF packet can be sent for 5 different purposes. You can use the packet to say hello, you can use the packet to say database description, you can use it for request, update or acknowledgement. So for all the 5 cases, when you make a packet, some part is common for every packet, and this part is called common header for everyone, and this is of 24 bytes. We already discussed. This part is 24 bytes. Now, out of these 5 packets, one packet is called update packet. Now, when you send update packets, now update packet is of 5 kind. All the 5 kind will use some common format, which is of 20 bytes. That means when you send update packet, this 44 byte is common for every packet. 24 byte is a common for OSPF packets, and 20 byte is common for update packets. So as a whole, 44 byte is actually common for update packets. Now these are the fields in the common header. Now these are the field which is used in every packet. Either you are sending for acknowledgement or for update or request. Is the version number, type, message length, the area identification. Each area is having one identification. We write the ID of this. Then authentication type we discussed. We have values 0 and 1. 0 means no authentication is required. 1 is some authentication is applied. If the value is 1, then you have something to write here like password. Okay, so this is 64 bits. So as a whole, this makes 24 bytes. Here type means the for what purpose you are using it. So we have 5 type, 1, 2, 3, 4, 5. One is what? Hello, database description, request, update and acknowledgement. Then this is your update packet. So out of 5 different packets, we are first discussing update packet. This is the most important packet. And in the update packet, we are doing advertisement. So we call it link state advertisement we are doing. We are updating the status of router to every other routers. So here, this is 24 bytes common. And then this is out of 5 means categories. Which categories you are using it? You are using it for network link update or router link update or this, or summary to boundary router or this. Okay. Now this is general. If you are doing update packet we are using for 5 different purposes. One purpose is router link. Second purpose is network link. Third purpose is summary to summary network. Fourth purpose is summary to autonomous system border router. Fifth is external link. So for all the 5, something is common. This part is common. What is here? Link state age. So age field will contain some value. When it is delivered from the router side, value is 0. It keep on going to other routers. The router will find out the transmit time and add this value here. This will tell us how old the packet is. So at any time when a router gets any packet, it will find out that how old this packet. E will tell us that this is a stub area, means the router is the only router that connects to the area border router. T defines us how many services are defined for this router. Link state type will tell us this thing. This packet is made for out of 5 values, which purpose you are using it. Link state ID For every purpose, we are assigning one ID. Who is actually going to announce the IP of that router? Sequence number. We are assigning one sequence number to every packet which is delivered. Checksum, we are using it to validate the values and length of this packet. Now LS type and LS ID. Based on the type, we are using the ID. If we are using the packet for router link, then you write the IP address of the router. If we are using the packet for network link, then you use the IP address of the designated router. Similarly, based on the purpose you are using, you need to write this information. Where you have to write this information? When you make a packet. So we'll look at the packet. This is the packet. So based on the type, you are writing the information of the ID. Now router link means the router, this router is actually informing about its link to the other routers. So it will say I am connected to one transient network, one point-to-point, one stub and one virtual. Now this is the announcement which this router want to make. So it will send a router link packet. So router link packet is sent by every router to every other router to inform what is my status, how I am connected in this internet. Now if you want to send a router link packet, then this is required. This is 24 bytes common for every kind of messages. 20 bytes is for update packet, and then if you are going to update, so you need to write this information. E is for stub, means the router is connected to a one network. B is this is a border area router? If this is 1, that means yes. Number of router links. How many links you are announcing? For example, in this case, this router has 1, 2, 3, 4. So how many links you are going to announce, that value will come here. Then ID and data. So what does it mean? It means if you are announcing point to point, then in the ID part you write address of the router, and data part you write interface number. That means if this router announce about this router, then it will write the IP of this router and the interface through which it is connected. This is required. If it is announcing about this kind of information, this network, then it will write the network address of this network and the mask. What is the mask of this network? So based on the type, we are going to use this information. So in the stub network, you are using network address and network mask. Now we'll use this information in one numerical. This is the scenario. This is a router which you want to announce its connection. So it has 3 connections. One is point to point. This is point to point. This is stub. So it will make a router link packet. In the router link packet, it has to write all this information. This information it has to write. Means we need to know link ID and link data. So if you look at this figure, how many connections are there? 3 connections are there. So this packet is prepared. This is our example. This router want to make a packet. So this is the first information. You write this is point to point. In the point to point, what is required? ID and data. So what is ID? In the point to point, ID is address of the neighboring router and data is interface number. So here you can see this is the address is this thing 10.24 this thing, and the interface number is 1. And what is this one? This one is tell us what is the type. So we have 4 type. 1 is point to point, 2 is transient, 3 is stub, 4 is virtual. And what is this? This is the matrix cost. So if you look at this is a point to point. So value is 1 and matrix is given to us 4. Similarly, we can announce this also. This is the IP of the router. This is the, what is this 2? Interface number, yes. So when you announce point to point, you have to write the IP of the router and the interface to which you connect. So this router connects through this second interface. And what is this one? Type. Type is what? Point to point. One is means point to point, and this is a matrix. Now, in the third is stub network. In the stub network, what is required? You need to write the address of the network and the mask of the network. This is the type. Type is 3. And this is the metric. So this is how this router means if this router want to send a router link packet, then this is the answer. Now network link. Network link means network is announcing how it is connected to different routers. This is called network link. Now network itself cannot announce, so actually one router has to take as a responsibility of this network, and we call it as a designated router. So in this case, what is required? You need two things only. You need to know what is the network mask, means the mask of this network, and how many routers are connected, the IP of all the routers. This is only sent in the case of stub network. So if the stub network is there or transient network is there, then only this kind of packet is delivered. No other scenario we use this kind of packet. So this is example here. This is the topology given to us, and network link packet need to be delivered. So we know this is a IP address. So in the packet we write the IP address. Sorry, we need to write the mask, because if you look at this, we need to write the mask here. So in the packet we write the mask based on this information. So the mask for this address is this one. Prefix is 24. And then also you have to write the IP of all the attached routers. These are the IP. Now, if you are asked to find out who will announce the router link, out of this topology, who will announce the router link? Is router announcing its own connection, right? So here, this also announce, this also announce, this also announce. All will announce. All will announce. Okay, this is one answer. Which router will send out a router link LSA? The answer is R1 also announce about its connection. R2 also announce about its connection. You understand? R3 also announce. So all will announce. Now, if I ask you write a packet for this announcement, how the R1 will announce this information? So when the R1 will send this information, what it will write? It is a stub area, right? So in the stub area, what is required? We need to know what is the network address and then the mask. If you remember, we did one numerical here. Here this router is announcing about its stub network. So what is the entry he made? The entry is this thing, the network address and the mask. Okay. So in this case, if we want to find out the router link information, we need some more information, like what is the address of this network, what is the prefix value. But in this question, it is only asked which router will send the router link packet. So the answer is R1 will send, R2 will send, R3 will send, all will send. Every router will share this information to every other router, that what is its status, how it is connected to other links and networks. Okay, is a packet delivered to inform every other router what its own status, how it is connected to other networks or router. Okay, so here if I ask you in this topology, which router will send this router link packet? So your answer is every router will send, because router link is sent to every other router by every other router. Each router is sending this packet to every other router. So in this case, all will be sending this packet. Okay. If I ask you in this scenario, who will send the network? This is the answer. Who will send the network link? Network link is used when the network has to announce its status. So it has two cases only. One is this case when network is connected to only one router, or network is connected to many routers. This is the case where network link packet is used, or you can say wherever you see you are using designated router, then network link is used. So for this network, R1 will take the responsibility. For this network, R3 will take the responsibility. For this network, out of these three, anyone will take responsibility. The one who will be acting as a designated router. Now, who will be taking responsibility? Actually, initially, every router will claim what is the priority value, or you can say what is the capacity. Based on the capacity, means what is the minimum delay, maximum throughput, the bandwidth, the processing power. they'll declare their own priority value. The one who is having the highest priority will be chosen as a designated router. So out of these three, one will take the designated router value. So who will send? Everyone will send. So for network N1, R1 will send. For network R3, this will send. For network N2, any of the three will send. So if network 2 has to send a network link packet, what is the packet format? So what we need is, we need to know what is the address of this network. Again, I go back. In the network link packet, we need only this thing. What is the mask of the network and how many routers are connected to it. So when you, if I ask you to make a network link packet for this scenario, then what you will do? You may be asking that what is the mask for this network and what are the IP of this routers. Then only you can make a packet, because in the packet you have to write the mask of this network and the IP of this routers. Okay with this? Now summary link to network means this router is informing the network of this zone to all the routers inside here, so that inside router will know what is the status outside. So, or you can say this packet is only used by area gateway router. This is only used by area gateway router to inform the other routers that what is the scenario outside. Here we only use the network mask. The network mask of this network, which is acting as a backbone network. We call it area 0 or backbone zone or zone 0. So the mask of this network is, we need to write it here. Then network will be performing many services. So if it is said network is performing 2 services or 3 services, then we have to repeat this. Service number 1 and what is the value assigned, service number 2, what is the value assigned. This we have not covered, but for every services we have a defined value. Then the next packet is, this is informing what is my IP, so that any router in this area, if want to send any packet to the outside, it must send this to here. So again, its format is again same like the previous one. This send to the area border router will send to the area. So here it is the same thing. So if this network is different from this, you can write the network address of this. If it is connected to the same network, then you simply write the network of this backbone. So it is same like the previous one. And then the external link. Now this is a little complex here. Here our purpose is to find how any router can send any packet to other autonomous system. Now this is one autonomous system. In the external link, we talk about that how the router will know the status of the routers which are outside this autonomous system. So here this is one autonomous system. Let's say this is autonomous system here. This is AS1, this is AS2, and also there is one gateway autonomous system, means this router which is acting as a gateway for this autonomous system. So now they are actually connecting with each other, they are communicating, and this is done with the help of inter-domain routing. So with the inter-domain routing protocols, we need to know, means this router is actually maintaining many tables. It meant one table to hold the information of this own autonomous system, and one table for its own system, and the other table is for the outside this autonomous system. Now outside structure is now to be informed to every other router. This is done with the exterior link packet. So this packet is a little complex, and at this time we do not, cannot get more information because we didn't cover this inter-domain routing so far. But we can only discuss what is the objective. The objective of this packet is to get the information about the routers or the structure outside this autonomous system. This is the objective of external link packet. And this is only used by this border gateway, means the gateway router which is sitting at the autonomous system. This packet can only be used by this router. So these are the 5 different update packets